Hey everyone, welcome to my next video. This next one is going to be 2.4. This is graphs of tangent and cotangent. So let me write out our title. Okay. So tangent and cotangent actually do have some differences when it comes to like period and stuff like that. And there's not much that's different. It's actually just the period, but I'm going to write all of this for us. So first we're just going to work on tangent. So the original tangent graph will go through this general form. A times tangent bx minus c plus d. And hopefully you remember me kind of giving these for sine and cosine. You know, I wrote them all the same way. The numbers are always going to be in the same spots. You know, they're always going to do the same things. The only difference here for tangent, as opposed to sine and cosine, and then also secant and cosecant, is the period is different. So the period, I'll remind you of what that is. This is the domain in which one cycle appears. And for tangent, it's going to be pi over b. And it's going to be for like that for cotangent as well. I'll make a note here. Cosine and sine were 2 pi over b. So tangent is only pi over b. Phase shift will still be the same. We'll do c over b. Vertical shift will still be the same. That'll just be d. Amplitude will still be the same. That's absolute value of a. The other difference is that we're going to have to watch out for asymptotes. So I talked about this last time, like in our last video. But an asymptote is a line that our graph approaches but does not reach. So a line that our graph approaches, meaning it's really, really close, but it does not actually reach that line. And it also means that it can't cross that line. And the reason that you have asymptotes is because sometimes there's going to be y values that you're going to see undefined. So if we get undefined as a y value, we have an asymptote. Also remember that they are drawn as dotted lines on our graph. And so first I just want to remind you like what tangent is. So a big way we'll talk about tangent today is I want to remind you that tangent is equal to sine over cosine. And so if we want to talk about the original tangent graph, I'm going to first graph that and show you, what we're going to be working with. So I'm going to draw the little unit circle over here. So I have 1, 0, that's 0, pi over 2, pi, 3 pi over 2, and it comes back around to 2 pi. Up here I have the point 0, 1, negative 1, 0, and 0, negative 1. Now tangent also goes through the points, the main, I call it the big five. We can go through the points zero, pi over 2, pi, 3 pi over 2, and 2 pi. Now if we remember that tangent is sine over cosine, when I'm looking at tangent 0, I'm going to take my sine value over my cosine value. So remember, all these points are cosine, comma, sine points. So the cosine is the x and the sine is the y when I look at these points. So at 0, tangent would be 0, oh, I didn't mean to erase. Tangent would be 0 over 1. I'm getting that because it's the y over the x. And you can remember that as well. That's how we talked about it in 1.4, as I wrote y over x. So this simplifies to 0. Now the next one, I have 1 over 0. This is undefined. The next one, I have 0 over negative 1. This is 0. Next, I have negative 1 over 0, which is undefined. And lastly, I'll have 0 over 1, which is 0. Now, tangent is actually a pretty interesting case. We are only going to look between asymptotes. So what we will find is that we are only going to use these points right here to help us graph. Now, if I graph this as it is right now, so I've got pi over 2, pi, 3 pi over 2. I know that I have asymptotes at pi over 2 and 3 pi over 2. That's because it says undefined right there, so that's where I have an asymptote. Problem is, if I plot this 0 here, it doesn't really help me with the shape at all. Like, I don't know how I'm supposed to make the shape look. So what we can do is we can actually use the midpoint method that I brought up in 2.2 to find more points to plug in. So for instance, I'd really like to know, I need another point here, and I also need another point here. Between pi over 2 and pi, I would do pi over 2 plus pi, and then divide by 2. We can also think about it this way. I can think about what would go right here if I'm looking at like the unit circle. And so If this is 180 and this is 90, right in the middle of those would be 135. Well, 135 written in radians would be 3 pi over 4. You can also just show the work of actually adding those angles and dividing by 2. Now if I look between pi and 3 pi over 2, I would have pi plus 3 pi over 2 over 2. This can be written as 2 pi over 2. So this would give me 5 pi over 2 divided by 2, which is 5 pi over 4. So this gave me 2 more points to use. So I now have 3 pi over 4, and I have 5 pi over 4. Next, I can plug these values in. So if I want to plug them into tangent, that means right here I'm looking at tangent of 3 pi over 4. Now tangent of 3 pi over 4 is going to be a reference of 45 degrees. So the answer is going to be 1, but I'm in quadrant 2, so it'll have to be negative. So that tells me that for this point, I actually come down to negative 1. Now between here, if I plug in tangent of 5 pi over 4, that's in quadrant 3, reference of 45, so it's actually going to be a positive 1. So here's what my general shape looks like. It looks something like that. So this is really the process of graphing tangent. A little bit different from sine and cosine. So of course, I definitely think that we should do some more of these. I also just want to mention that the shape of tangent will always look like this. So the general shape for tangent will always look like this inside those asymptotes. So let's go ahead and do an example where I change a little bit up. So example 1, I'll say graph 1 cycle, state the period, amplitude, any transformations, asymptotes, and then also I'll say clearly label 5 points. And so here's kind of the process that I would use. So first one we're going to do is y equals tangent 2x. And so I want period want the amplitude, I want the phase shift, vertical shift, and this one we actually have a new thing to find, which is asymptotes. So for my points, my x values, here's what I like to do. Earlier, when we graphed the original tangent, we found that setting it equal to 0 and setting it equal to 2 pi, these points right here didn't actually matter. So I'm not going to worry about them for this graph. So for my x values, I'm going to start off with the inside of the parentheses. And if you show that you're setting them equal to all the big five, that's totally fine. But I'll tell you that your first one and your last one aren't going to matter. So I don't really need them. So we're going to find these middle ones. So to solve for x, I'm going to divide by 2 or multiply by 1/2, depending on how you want to think about it. So this is going to give me x equals pi over 4, x equals pi over 2, and x equals 3 pi over 4. Now, this is only going to give me my 2 asymptotes and my middle point, so I would like to find 2 more points. To do that, I'm going to find the middle of these two, so I'm going to add them together and then divide by 2. So I'm going to show this process. Pi over 4 plus, I can multiply this by 2 over 2, so that I get 2 pi over 4. So I get 3 pi over 4 times 1/2. So that's going to be 3 pi over 8. Now between these, pi over 2 plus 3 pi over 4 divided by 2. So I get 2 pi over 4 plus 3 pi over 4 divided by 2, which will be 5 pi over 4 times 1/2. So 5 pi over 8. So I did tell y'all that I like to usually give you a table for your xy points. So my x points I've got are pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, and 3 pi over 4. Now I'm going to go find my y's. Now anytime you want to find your y values, you can always just plug in the x values that you got. So if I do tangent 2 times pi over 4, I would get tangent pi over 2, which is undefined. If I plug in my next one, I get tangent 2 times 3 pi over 8, which is tangent 3 pi over 4, which we get -1. Next, tangent 2 times pi over 2 gives me tangent pi. That'll give me 0. Tangent 2 times 5 pi over 8 will give me tangent 5 pi over 4, which is positive 1. And lastly, tangent 2 times 3 pi over 4 will give me tangent 3 pi over 2, so undefined. So I got undefined, -1, 0, 1, undefined. I'll plot these on my graph. So I have asymptotes at pi over 4 and at 3 pi over 4. I have a 0 here, -1 here, +1 here. And there's my rough sketch. Now I did forget to go find period, amplitude, phase shift, all that stuff, so we can go ahead and do that now. So my period is pi over b, so in this case that's pi over 2. You'll notice that that is going to be the difference between your last x value and your first x value. So if I do 3 pi over 4 minus pi over 4, that's 2 pi over 4, which is pi over 2. So that checks out. That equals the period. Amplitude is this number in the front, so that's just going to be 1. Also, you'll notice that, see how from the middle I went to 1 and -1, -1 and then 1? That's the amplitude doing that. So like for instance, if this had said, hypothetically, if this had said 2 tangent 2x, this would have been a -2 and this would have been a +2. And I'll show you that maybe in the next one. I'll do some more like vertical shifts and stuff like that. My phase shift is C over B. So in this case, I do not have a C, so it's just going to be 0. This one's always a little weird because that would have been this point right here for the phase shift. So it's fine that we started at pi over 4. It's because there is actually a point up here, and that would have been 0. My vertical shift, I have none because I have no D value. And then lastly, my asymptotes. I have asymptotes at x equals pi over 4. I don't know why it's writing like that. X equals pi over 4 and x equals 3 pi over 4 is where my asymptotes lie. Now something I want to show you is the way that so the proper way to write asymptotes is actually to take your first asymptote and you add the period times k. Now I'm okay if you just list them out, but I want to tell you that for my math lab, they're going to want it with the k in there. The reason for this is because you got to remember that this graph goes on forever and ever, like it just repeats itself. So you really have an infinite number of asymptotes, and you'll find that every time you add the period, you're going to find a new asymptote. So that's really the proper way to write asymptotes. I'm fine with either of those that I just gave you. You can write it whatever feels better for you. And I want to show you this one on Desmos just to give you an idea, what it looks like if you draw it real nice. So tangent 2x. Let me zoom out. So you can kind of see that shape in there of what we're seeing. And so let's see, our asymptotes lie at x equals pi over 4. And my next one was at x equals 3 pi over 4. So if you look here between these two lines right here, the green and the purple, that red is like what we just graphed. So let me go ahead and do another one of these. This one I'm going to maybe do like an amplitude and a vertical shift. So we'll say this is part B, and this one I'll do y equals, let's do 2 tangent x minus pi over 3 plus 1. So I got a few different things going on here. And I want the period, I want the amplitude, I want the phase shift, vertical shift, and asymptotes. My A value is 2, my B value is 1, my C is pi over 3, and my D is 1. So for my period, I get pi over 1, so that's just pi. Amplitude is 2, phase shift is pi over 3, vertical shift will be 1. And I like to write in my asymptotes after I find the x values. So let me go get those. So again, we can do the thing where we set the inside of the parentheses equal to the big 5. The thing you have to be careful of, though, is that you'll find that this one and this one won't actually matter. Now, this one can confirm your phase shift, so that can be nice, but they will not actually matter for our graph. So let's see. For my first one, write it up here. I'm going to add pi over 2. So let me write it like this, actually. Sorry, pi over 3. Pi over 2 plus pi over 3 is what I meant to say. So let's see. This is going to give me x equals, this is the same thing as saying 3 pi over 6 plus 2 pi over 6. So this one's going to equal 5 pi over 6. For my third one, sorry, like for this one is what I'm meaning to say. Let me go ahead and number these, 2, 3, and 4. Or if you want to label them 1, 3, and 5 maybe. The reason I'm doing that is because I'm going to need points in between these, so I'll label those my 2 and 4. So this one, I'll get 3 pi. I hate when it writes big like that. 3 pi over 3 plus pi over 3. So this one is 4 pi over 3. Then my last one, so this one down here, is going to be 9 pi over 6 plus 2 pi over 6. So this is 11 pi over 6. And so there I was just adding fractions. Now I need my like in between ones. So I need like one here, my second one, and technically a fourth one here. So for this, I'm going to add my two together. So 5 pi over 6 plus 4 pi over 3. And then I'm going to divide it by 2. So I'm finding the middle between these two. Adding fractions, so I get 5 pi over 6 plus, that would be 8 pi over, 8 pi over 6. And then I'll multiply that by 1/2. So this one's going to give me, let's see, 5 plus 8, so 13 pi over 12. My next one, get 4 pi over 3 plus 11 pi over 6, and then divide it by 2. So this is going to be 8 pi over 6. And I'm just multiplying that by 2 over 2. That way I can get the denominators the same. Plus 11 pi over 6 times 1/2. So this is going to give me 17 pi over 12. And so again, I'm just adding fractions there. That's just arithmetic. So for my graph, I'm going to have 5 pi over 6, 13 pi over 12, 4 pi over 3, 17 pi over 12, and then 11 pi over 6. Now realistically, I'll tell you that I actually just like to use transformations. Whenever I do tangent, I actually do not like to plug in points. So I'll write you what I mean by that. Let me just write these into my table first. So what I mean by I like to just use transformations is that I know that my first point and my last point are going to be asymptotes. I know that. Because that's why I've done this method the way that I've done it, you know. I know that my middle point, so my third point, is going to have to be the middle of my graph. Well, that happens at the vertical shift. So if I'm going to go up by 1, that means the middle of my graph has to go up by 1. Then I like to use the amplitude. So if my amplitude is 2, that means that I should go 2 above this and 2 below this. Like the 1. And I also know that my tangent graph should look like that. So this one's going to be up here at -3, and this point's going to be down here at -1. And then I just draw it in. And as best as I can, you know, it can't be perfect. So that's actually how I usually graph tangent. I do not usually plug in y values. I just write them in. So again, I knew that these were undefined because the first one and the last one when I do tangent is always like that. I knew the middle one would have to go through my vertical shift. And then for the others, I just used the amplitude. And there you go. So my asymptotes for this are x equals 5 pi over 6 and x equals 11 pi over 6. Or you can write it as x equals 5 pi over 6 plus pi k, which is the period. So you'll always add the period if you want to write it this way. Now let's go ahead and talk about cotangent. Now, so for cotangent, remember that it is, instead of sine over cosine like tangent, it's cosine over sine. Or you can write it as x over y. And so just like with tangent, I'm going to make my table. And I'm just going to use the basic, let me give myself a little bit more room actually. I'm going to use the basic 5, like big 5 points. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. This one, we're actually going to see our asymptotes are in a different spot. So we're going to find our x points a little, like the same way, but they're going to be a little different from tangent. So I always like to reference back to the unit circle. So this is 0, pi over 2, pi, 3 pi over 2, looping around to 2 pi. So I get 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So for these, remember it's going to be the x value over the y value now. So I get 1 over 0. Oh, did I write this right? Yeah. Which is going to give me an undefined value. At pi over 2, I get 0 over 1, which is 0. At pi, I get negative 1 over 0, which is undefined. 3 pi over 2, I get 0 over negative 1, which is 0. And lastly, I get 1 over 0 again, which is undefined. So cotangent's actually kind of interesting because you're going to see your points landing a little differently for these. So these, we're actually going to look between these first 3 points. And that's because of where I'm seeing 2 undefined points. So it's really just because of where I'm seeing the asymptotes. So if I look between 0 and pi over 2, I can do 0 plus pi over 2 divided by 2, which is going to be pi over 4. And then if I want to point between pi over 2 and pi, this would be, sorry, that looks bad. Pi over 2 plus pi is going to be 3 pi over 2, so I get 3 pi over 4 here. So here's what the graph of cotangent looks like. We've got 0, pi over 2, oh, sorry, I forgot my pi over 4. Pi over 4, pi over 2, 3 pi over 4, and then pi. Now for this one, my asymptotes are lying between 0 and pi. My middle point is here. And now if you plug in the values at pi over 4 and 3 pi over 4, what you will get is you're actually going to see a little bit of a swap happen. So this is going to be positive 1, and this one's going to be negative 1. So here's what changes. Now our graph looks like this. So for tangent, remember it was like this. For cotangent, it flips. And then you also see your asymptotes lie in a different place. So I can go ahead and do a problem. So this will be example 2. And I'm going to ask all this stuff, but I'm just going to write it. I'm not going to write it all like I usually would. I'm just going to go ahead and say y equals and start with my graph. So let's do one with, let's do an amplitude of 3. And then we'll do cotangent. And then let me just do 2x, and then I'll do plus 1. So I would find my x values the same. Oh, let me write what I would need. That's what I get for not writing it out. So period, amplitude, phase shift, vertical shift, and then I've got the asymptotes. So my period is pi over b, just like with tangent. So in this case, it would be pi over 2. My amplitude in this case is 3. My phase shift is 0. My vertical shift is 1. And I don't know where my asymptotes are. I'll get them after I find my x's. So for my x values, I'll do the thing where I set equal to the big 5. But I'll find that I'm actually not going to use all of them. You'll find that for cotangent, you actually only need the first 3. So here I'll get x equals 0. So I'm dividing by 2. I'm just solving for x. So I get x equals pi over 4. And this one, x equals pi over 2. Now I need to find the points in between these because I'm going to need more to graph. Because remember, if I go and graph this as it is, I have 0, pi over 4, pi over 2. I know that the asymptotes are going to be at the first and the last one. So I did just find that, which is great. And I know my middle point is going to be at pi over 4. Now we have a vertical shift, so that means it's going to go up by 1. But I need 2 more points to be able to really draw out my whole graph. So if I'm looking for points in between these, I'm going to do 0 plus pi over 4 divided by 2. So this is going to give me pi over 8. And then between these two, pi over 4 plus pi over 2 divided by 2 be pi over 4 plus 2 pi over 4 divided by 2. So that's going to be 3 pi over 4 times a half, so 3 pi over 8. And then I like to use my amplitude for the rest of my y values. So if I have an amplitude of 3, that means I'm going to have to go from the middle. I'm going to go up by 3, and I'm going to go down by 3. So let's see, 1, 2, 3. So that would hit like -2. So I went 1, 1, 2, 3 to get up to 4. And I went 1, 2, 3 to get down to -2. And then I know that my cotangent graph is supposed to look like this. So this one's going to be up at 4, and this one's going to be down at -2. And then I would just draw my general shape in there. And that does not look super good, but it's fine. We get the point. Now again, for your asymptotes, remember that you can also write it as x equals the first asymptote plus the period. So in this case, it would be x equals pi over 2k. And that's what my math lab is probably going to make you do. And we can go look at this on Desmos real quick, just to see what we're looking at. So this was 3 cotangent, then I did 2x, then I did plus 1. So here's our graph. We can check out our asymptotes if we want. So our first one was at x equals 0, and then our next one was at x equals pi over 2. So they're doing it in black, which is kind of terrible for the x equals 0, but they're putting it right here. And then our other asymptote is here. They're just not color coding this one very well. And we can see our graph has got that shape that we wanted. Now, I like to be pretty clear about what I test on. So, for your test, when it comes to graphing, what you should expect from me is to see a sine graph, a cosine graph, and a tangent graph. I will not test you on secant, cosecant, or cotangent. I just don't usually test on the reciprocals just because, honestly. Not really any reason. I just don't usually do it. I think they're a little bit less common to see, I guess, so. But I like you to really know sine, cosine, and tangent. So that's what you should expect on your test. Now, this is my last section before test 2. So I will also do like a review video. So if you are finishing up this video, if you're feeling like you have any questions or you really need to see me graphing more of a certain thing, or maybe you need to see stuff from chapter 1, go ahead and send me an email and I will try to maybe get questions in before I actually make the review video, in case there's something that students really need to ask me about. But that's going to be it for this one. I hope you'll have a wonderful day and good luck on your studying. Bye-bye.